Hi everybody, my name is Nathan Trudeau and I will be your host on behalf of the UC Irvine Solar Car team for this fall 2020 design review. As one of 3 electrical leads on this team, I am in charge of telemetry and low voltage, which is essentially the embedded systems, dashboard, and safety systems for our vehicle. So come spring of 2021, we are projected to create a vehicle that looks like such. And as you can see, the dashboard is right there. So as telemetry and low voltage lead, I'll have to integrate that dashboard and make sure our electrical systems are performing as they should when our vehicle is complete. Come 2 to 3 years from now, we'll be looking to compete in the American Solar Challenge, which is a national challenge against other universities who are also building solar cars, and will be performing in a race over 2,000 miles purely on renewable energy and comparing our performances to each other. It's a very, very friendly, open challenge, and of course, it's all renewable energy. It's all for the fun of it, and it's all for science. So everybody here is extremely ecstatic to be working in this field and pursuing this kind of profession. And to get started, at the beginning of the quarter, our previous electrical team had left us with a pretty large task. A lot of our materials were scattered on the shelves in the back there, not very well organized. We had an electrical system, but it hadn't been touched in a really long time, so we had to kind of figure out a way to reverse engineer it from the start of this quarter. And here's a closer image of the front, and here's an image of the back. You can see the back is very unorganized and pretty confusing to pick up, even for an advanced engineer. And this is the documentation that we were left with. So from this to this, it's pretty hard to map what's going on from the physical electrical system to the schematic. And of course, this schematic is very logic-based. The labels are pretty generalized, not very specific. So we had a lot of things to improve on here. So it started with organization of materials, which we did. We took everything off the shelves, organized it based on importance/logic, and maybe even price or size. We did a lot of organization, which was really helpful for our team, so that we were then able to go and validate the existing electrical system. And once we did so, we started deconstructing and reverse engineering the system by labeling all of the wires and putting pin-to-pin connections on a detailed spreadsheet. And in doing so, we were able to create what I like to call a wire list. And this full wire list here shows the gauges, the type of wire, the color, the length, and both pin A and pin B connections of the wires, and the appropriate connectors needed for those connections to happen, whether those be quick disconnects or ring lugs or bare connections or screw terminals. We made sure to make note of all of those details. And we did the same for our high voltage mock system, which is really nice for our high voltage guys. And of course, all of it had a purpose. We wanted to not only purchase materials ahead of time, like connectors and wires and spools and such, but we also wanted to draft our schematics and make very, very detailed pin-to-pin schematics. And here is, we're calling it version 0.5 because it's not completed, but here's our first version of our official low voltage schematic. And we decided to go with Fritzing, and Fritzing is a program that's much more user-friendly than our previous schematic drafting program. There's much more colors, much more label opportunity, and they also have a lot more libraries for Python-based embedded systems like the Raspberry or the Arduino Uno. So Fritzing was something that was really important for our team to switch to for the longevity of it moving forward.